Hi, I'm Eric. Let's talk about my paper, Understanding Version Control as Material Interaction with Quickpose. This paper presents a version control system, Quickpose, to show how we might build version control systems which support users treating code as a material. Let's start with a situation you've almost certainly been in. So you're making something on the computer, a piece of writing, an image, or some music, and you get to a fork in the road. There are two ways to proceed. You could use one font or another, for instance. And it feels like you have to kind of try both to see which one will work out. So you save a version of this file and name it something like project font. You keep working on the other parts of the project. And over time, you realize that maybe the other font you considered was maybe the right choice after all. And so you go figure out which one you used in that other file and make the change in your current version. By the end of your project, you probably have a whole mess of files like this. Things that you'd like to keep around because they represent the different choices and dimensions of the work at hand. Of course, some of the technical challenges surrounding merging and storing different versions are already addressed in systems like Git. But let's focus on the interaction in this kind of situation. It's choices like these and how we keep those choices around as active parts of our work that help us figure out where we're going. We aren't sure which font or color or sentence is the right one. We have to explore and iterate in other directions and work out the rest of the project. Working like this is a gradual negotiation of all the elements together. We're rarely 100% sure a choice we've made will always be the right one. So we have to keep around our different options in case our decision changes as we work out the other elements of our project. For folks like anthropologist Tim Ingold or painter James Elkins, the word that comes to mind here is material. When an artist, artisan, or designer talks about using a material, Ingold and Elkins think that they mean something like our example. We aren't instantiating our thoughts directly into the world, but rather we engage in an ongoing conversation with our materials. We let them inform our practice as we explore and discover the work we want to do. For this reason, in our paper, we call this way of working material interaction. This will be the central concept motivating the rest of our paper. So now we're set up to ask our research question that beyond the technical abilities of Git to merge and store changes, how might version control systems support material interaction in programming systems? In other words, how could we use version control to support treating code as a material? To answer this question, we built Quickpose, a version control system for the creative coding platform processing, and ran a longitudinal study to understand our users' programming behaviors with the tool. To develop Quickpose, we had to go back to the broad discussion in HCI, anthropology, art and design practice, and elsewhere to try to distill some key ideas from this literature to inform our design principles. We brought out 3 key claims from this existing literature that would offer us a place to start in thinking about instantiating these ideas in software design. First is the reciprocal discovery of goals and materials. This is the idea that as we work with materials, our goals change. What we learn in our exploration with materials cause us to think differently about what we're trying to do. Second is that we have local knowledge of materials. This is to say that we learn things about materials by actually working with them, and that knowledge starts as a tacit or intuitive practice. A ceramicist, for example, learns how a certain glaze composition affects the outcome by trying out a few different glazes and comparing. They may not have a general theory of glazes, but they don't necessarily need one. They instead build the practical knowledge they need to continue working as it's required, abstracting and building more formalized knowledge when it becomes necessary. Our third point is that our practices of building, storing, and using knowledge about materials center around contextualizing the work, rather than generalizing away from it. To return to our ceramicist, they might write a certain glaze composition on pieces of paper, which they place on each of their pieces. The information that each note contains is only valuable as it relates back to the artifact. When the ceramicist wants a certain appearance for their next project, they'll find the piece that matches and look for the note to see how they can make the same glaze. In a bigger sense, we can say that how we annotate information into a material interaction seems to focus on helping contextualize and interpret the artifacts we've generated in a way that the artifacts themselves are always required. We then formulated a handful of design principles for Quickpose, our version control system, for the creative coding platform processing. Quickpose provides 1, a direct manipulation, one-click navigation, and forking interface. 2, because it presents versions on an interactive board, users can flexibly group, arrange, and annotate their versions. And 3, Quickpose automatically checkpoints versions on every run, which supports fast iteration and navigation between versions without fear of changes being lost. We discuss other features and the implementation of Quickpose in detail in the paper. Because we don't have any clear existing metrics to evaluate the success of Quickpose, we instead used Quickpose to try to study material interaction behaviors and the initial promise for some of the measures we try to propose. To do this, we went back to our claims of material interaction and asked what practical measures might be plausibly linked to these claims. Our initial measures, presented here, focus on behaviors of forking, backtracking, and navigating between versions, and how that could indicate different kinds of goal reformation and interactive exploration and variation. In addition, we looked at how annotations function to support contextualizing and interpreting each version. We then ran a 6-week longitudinal study with 3 expert processing users, passively gathering data about their use of Quickpose on their own projects. We also conducted interviews with our participants halfway and at the conclusion of our study, which we coded for evidence of our themes. We compiled both our qualitative and quantitative evidence for each of our themes, and as preliminary evidence that the measures we offered might help us understand material interaction behaviors. Please see the full results section of the paper for more details. We found that our users frequently returned to far previous versions to start over in new directions. They iterated on disparate branches in parallel, and they navigated widely across their version history in the course of development. So, to summarize, with Quickpose, we tried to explore this idea of material interaction, to see how we might support programmers in taking up code as a material. Our study looked at what kinds of qualitative and quantitative evidence might indicate material interaction. As part of our contribution, we also present an updated set of measures based on what we learned in our study that we hope will be a strong starting place for future research. There were 2 big themes of our reflection on this project, which makes up the discussion section of the paper. The first is the idea that a tool like Quickpose seemed to be an interesting place to study how these programmers worked through their ideas, journeyed through their iterations, explored new ideas, and perceived their work. One of our participants described the Quickpose canvas as a mind map, which was a term we hadn't used before, but really resonated with what we were trying to do with Quickpose as a platform for studying material interaction. Looking back on the system and the study, it seemed clear that a major part of why this system is interesting for HCI research is that it provides a platform for users to express how they're thinking about their work, and that this gives us a unique insight, maybe, into how people work that might be significantly harder to get otherwise. We think that this direction of building tools as platforms for research might be a promising direction for studying version control behaviors over time in order to get the rich data we need to inform future design and analysis. Secondly, we don't try to present a validation of material interaction as a formal model of behavior. Rather, this paper was an interesting step to bringing some of the theory many of us in HCI find helpful and inspirational to make some concrete claims on the design of version control systems and programming tools. We think a theory of material interaction, specifically for interface design, might come out of a mosaic of these ideas being put into practice, one of which is our paper here. This is to say, it might be itself a process of material interaction, as we iteratively explore material interaction behaviors in new systems, new communities, and new domains. We think that there are a lot of exciting directions to pursue in the future from this work. In one way or another, material interaction is something all of us participate in, and supporting it with computer interfaces could mean tools in lots of new domains. Additionally, we could also think about the ways traditional software engineers already treat code as a material, and how we might build version control systems to support and facilitate that interaction outside of creative coding. For the full paper, or to try Quickpose out for yourself, please go to ericrawn.media/Quickpose. Thank you so much.